Next, we're going to find the convective condensation level. Remember, we found the lifted condensation level by moving up from the surface using the surface temperature parallel to a dry adiabat, and then up from the surface from our surface dew point of a wet adiabat, and where they met is the lifted condensation level. So you'll agree with me that at this point our parcel is saturated. So from here on up, it's going to move up the wet adiabat at the saturated lapse rate. So all along this little segment that I drew here, the lifted parcel, and imagine that it's lifted by an approaching cold front or orographically, all along this line here, the lifted parcel is colder than the environmental air that's measured by our radiosonde. So this air is still stable, so this is still stratiform clouds. But right about here, it crosses the temperature line. And if you can imagine that if this parcel of air is lifted up just a little bit, it'll suddenly be warmer than the surroundings, and it no longer needs a front to lift it. It's going to convect naturally because it's warmer than the surrounding. So this level right here where the lifted parcel trace crosses your temperature line is your convective condensation level. So here's your lifted condensation level and your convected condensation level. Over here, your lifted condensation level we found was about 1,800 meters. Your convective condensation level was around 3,500 meters. So if we could actually continue up the wet adiabat with this trace, and everywhere along this trace where the trace is to the right of the temperature line is convective clouds, a convective situation. Until right here where it crosses the temperature line again, and this would be the top of our convective layer. And that's around 10,000 meters. So we have lifted condensation level, convective condensation level, and top of our convective layer. So the lifted condensation level would be the base of any stratiform clouds, and then ascending you'd have base of convective clouds, and all the way up to about 10,000 meters. So when you see something like this, where the temperature line and the dew point line are relatively close together like that, you know that this is all clouds in here. So this deep convective layer might suggest to you that this is a deep rain shower or maybe even a thunderstorm. And remember how we found the tropopause by looking for when the your sounding suddenly becomes very, very stable. This is your stratosphere up here. So the top of this convective layer is almost near the tropopause, so I would suspect that this is actually a thunderstorm here.